Topic of this video is PL7. I can fully factor a polynomial. Sometimes this means that you just factor out the GCF. Sometimes this means that you factor the trinomial into two binomials, and sometimes it means that you need to do both of those things. So we will be addressing PL6, PL4, and PL7 in this video. If you're watching the video, I hope that you have downloaded the extra practice worksheet that goes along with it and printed it. We will be working through the front together with some examples and guided practice, and then you will complete the individual practice on your own. I'm not posting an answer key on the website because I want you to come and check your work with me in class. So starting on that upper left example, the GCF only example right here, you should copy down this problem. 27x to the third y to the fourth plus 18x squared y squared plus 36x squared y. When you are asked to factor out the GCF of a polynomial, you are looking for the GCF, or the greatest common factor of the terms. So the greatest common factor that the terms share. In this case, we have a trinomial, 3 terms. So we're looking for the common factors of these 3 terms. I'm going to start with the ladder method. And when I do the ladder method, it's useful to look at the terms factors one at a time. So let's look at the coefficients first, 27, 18, and 36. Now you may be able to identify the greatest common factor of those numbers immediately. I'm going to pretend like I can't. Oh man. So that I can show you what happens in that case. So right away, I can see that 27, 18, and 36 share a common factor of 3. Each is divisible by 3. And so I'm going to start with the common factor of 3. And then I'm going to divide the polynomial by that factor, by 3. 27 divided by 3 is 9. And then 27x to the third y to the fourth divided by 3 is still 9x to the third y to the fourth. The variable factors are not affected by that division. 18x squared y squared divided by 3 is just 6x squared y squared. And then 36x squared y divided by 3 is 12x squared times y. Now you'll notice that the coefficients 9, 6, and 12 still share a common factor, which is 3. 9 is divisible by 3, 6 is divisible by 3, and 12 is also divisible by 3, with the variable factors not being changed. 6x squared y squared divided by 3 is just 2x squared y squared, and then 12x squared y divided by 3 is 4x squared y. We are done with the coefficients. 3, 2, and 4 do not share a factor other than 1. Moving on to the x factors that these terms share. We know that they share the factor of x because they all have an x factor in them, but they also share actually a factor of x squared because x to the third, x squared are all divisible by x squared. If we divide x to the third, which is x times x times x, by x squared, we end up with just x. I hope that you are comfortable with that division at this point. So x to the third divided by x squared gives me x, and I still have 3 in the y to the fourth factors. 2x squared y squared divided by x squared just leaves me with 2y squared, because x squared divided by x squared is just 1. Same thing here, 4x squared y divided by x squared is 4y. Looking at these terms, 3xy to the fourth, 2y squared, and 4y, we still have one more factor that these terms share, which is y. 3xy to the fourth is 3xy to the fourth divided by y is 3xy to the third. 2y squared divided by y is 2y, and 4y divided by y is just 4. We're done now because if we look at these 3 terms, 3xy to the third, 2y, and 4, they do not share any further common factors. So we have the GCF. The GCF is, oh my gosh, is the product of these common factors on the side. Those are all common factors, so the greatest common factor is 3 times x squared times y. 3 times 3 is 9 times x squared times y. Now that's my GCF, If an assessment asks you just find the GCF, then you're done. The GCF of 27x to the third y to the fourth plus 18x squared y squared plus 36x squared y is 9x squared y, or that's the GCF of the terms of this polynomial. If the directions say to write the polynomial in factored form by factoring out the GCF, we write the GCF and then we write the polynomial as the product of the GCF and this polynomial right here, which is the result of dividing the original polynomial by the GCF. I have this typed out over here because of my handwriting situation. This, let's make that purple. This polynomial right here, 9x squared y, I don't know why this is happening. I guess I have to write it myself. 9x squared y times 3x y to the third plus 2y plus 4. Go ahead and write that. 9x squared y times 3x y to the third plus 2y plus 4 is my factored form of this original polynomial. Factored form meaning the product of two factors, 9x squared y, and then the other factor is 3xy to the third plus 2y plus 4. We can check this factored form using the distributive property. 9x squared y times 3xy to the third would be 27x to the third y to the fourth. Check. 9x squared y times 2y is 18x squared y squared. That's correct. And then 9x squared y times 4 is just 36x squared y. So I am correct. This is my factored form. Again, the product of the GCF and the remaining polynomial. You are going to go ahead and move on to the next section of your table, the GCF only guided practice. Oh, never mind. I have this other kind of, it's not really a different method, but a different way of showing your work that I'm going to show you, which is using the box that we use for multiplication and working backwards. So the way that we use this box, this is great for those of you that are good at kind of just looking at the polynomial and identifying the GCF, but then the box allows you to check your work. So when we're using the box method or working backwards from the box, we're going to place each term of the polynomial inside the box, 27x to the third, y to the fourth, etc. And then we're going to work backwards to figure out what the dimensions of this box are, and that will give us our factored form. One dimension of the box is always going to be the GCF. So again, to use this method, you need to be able to just look at the terms and see the GCF, or at least realize when you've made a mistake. So we know the GCF of these three terms is 9x squared y, because 9 is the GCF of the coefficients, x squared is the GCF of the x factors, y is the GCF of the y factors. And then I'm going to work backwards. What times 9x squared y is 27x to the third y to the fourth? Or you could think of that as division, and that is just 3x y cubed. Same thing here, 18x squared y squared divided by 9x squared y, or alternatively think of that as 9x squared y times what equals 18x squared y squared, which is 2y. And then here, what times 9x squared y gives you 36x squared y? And that's just 4. You don't need to be writing this on your worksheet because you probably do not have space. So this box method, working backwards from our multiplication problem, gives me the factored form of my trinomial, with one factor being this dimension and the other factor being this dimension, 3x squared, 3xy to the third plus 2y plus 4. The reason I like this method is it gives me my check right here. I have already multiplied out, done the distributive property of the GCF times the remaining polynomial, and I can see that I'm correct. So you can choose either of those methods, the ladder or the box, or you can maybe just look at it. When I ask you to factor out the GCF, it is fine with me, and actually it's great if you can just look at it and identify the GCF and then the factored form. So go ahead and write this on your paper and then press pause. And when you come back, we will have the answer for you to check your work. So hopefully you pressed pause and now you're back. This is the answer that I am looking for. 15x y squared z squared times 3x to the third y z to the third plus 2x z plus 7. Sorry, this is kind of ugly. I'm sure Miss Courtney loves this example. If that is your answer, then you can just skip forward a little bit to the next example. If you need some help, here is my work. So I'm going to use the ladder method to start with. I'm going to look for a common factor of the coefficients. The one I see most immediately is 5. So then I'm going to divide through by 5. I'm going to go through this kind of fast because you can probably just see where you made a small mistake. Dividing through by 5, 9, 6, and 21 still share a common factor, which is 3. So I'm going to divide through by 3. That gives me this lovely polynomial. Looking at the x terms, we have an x to the 4th, an x squared, and an x. So the greatest factor that those terms share is an x. Dividing through by x, I have x to the 4th ends up with x to the 3rd. X squared divided by x is x. X divided by x is just 1. Looking at the y terms, my greatest common factor is y squared, which results in this polynomial once I do the division. And then z to the 5th, z to the 3rd, z squared, the greatest common factor of the z factors is z squared. Okay, so now I'm done with my ladder, and then I use that ladder to find my factored form. Again, the GCF is found as the product of these common factors. So 5 times 3 times x times y squared times z squared, which is just going to be 15x y squared z squared. And then this part down here, I've already done the division, which is the great part of the ladder method. And so that gives me my other factor in my factored form right here. So we know that 15x y squared z squared times 3x to the 3rd y z to the 3rd plus 2xz plus 7. When we multiply that out, we end up with our original polynomial. If you did the box method, it should look like this. We have each term of our polynomial written inside the box. And then we look at these terms and we identify the GCF, which is 15x y squared z squared. And then we work backwards to find the dimension of the other side of the box. Again, I'm hoping if you made a mistake, I can just go through this quickly so you can identify that mistake. I like this method because we've already checked our work. We know that 15x y squared z squared times 3x to the 3rd y z to the 3rd is 45x to the 4th y to the 3rd z to the 5th, for example. Sorry for these really unpleasant examples. Let's move on to something more fun, I think. The first example, trinomial to the product of binomials. We've had some issues with you guys understanding this vocabulary. So when we say trinomial, we mean, actually it should say quadratic trinomial. So it's something of this form. Let me write that. Quadratic trinomial. It needs to be quadratic. That's the only type of trinomial that we know how to factor into the product of binomials. So the product of binomials means this, the product, multiplication, of two binomials. Binomials, two terms. And actually in this case, since we have an a not equal to 1, it's actually going to look something more like this, but that's less pretty. So we are looking to write this quadratic degree 2 trinomial, 3 terms, as the product, multiplication of two binomial factors. This is where we're going to use our diamond and our box. So when we use our diamond and our box, we're looking for two numbers that multiply to a times c, 6 times negative 5, which is negative 30. Just a second. Two numbers that multiply to 6 times negative 5, which is negative 30, and then add to b, which is just 13. If my a would have been 1, I can still think of that as multiplying a times c, which would be negative 5, but we've just been thinking about if a is 1, we can just go ahead and put the constant in our multiplication area of the diamond. Anyway, a does not equal 1, so I need to write up here a times c. So we're looking for two numbers that multiply to negative 30 and add to 13. What are those two numbers going to be? There's no system of equations I can solve here, or maybe there is, but that's not what we're doing. We're finding two numbers that multiply to negative 30 and add to 13. So let's look at some factors of 30. So we could think, 30 and 1, we know that the bigger, in quotation marks, number needs to be positive since they add to a positive. That doesn't work. That would be 29. We can think of what? 15 and 2. It would need to be negative 2 to multiply to a negative. And that works. So 15 and negative 2 it is. I could have tried some other ones. I should have fake tried those, like 6 and negative 5. What else? 10, negative 3. None of those work. None of those add to 13, but 15 and negative 2 do. Okay, so when I'm filling out my box, original quadratic term goes here, original constant goes here. And then I take my 15 and my negative 2 from my diamond. And again, the reason we're doing this is we need the x terms to add to this middle term. 15x and negative 2x add to 13x. And then we also needed those two coefficients to multiply in the end to allow us to have a 6x squared and a negative 5. Okay, so now we're working backwards. We're going to identify the GCF of each row and each column. So the GCF of 6x squared minus 2x is just 2x. And the GCF of 6x squared and 15x is 3x. That's great because 2x times 3x is 6x squared. Some of you aren't really using this GCF method of the rows and columns, and that's okay as long as you're doing a really good job of making sure that your dimensions multiply to be the proper area here. Okay, so we could think of GCF of negative 2x and negative 5, or we could think what times 2x equals negative 2x? That's just going to be negative 1. And then here, what times negative 1 is 5? Negative 5, which is 5. Or what's the GCF of 15x and negative 5? That's just 5. And we are done. We have found the outside dimensions of our box. 3x minus 1 times 2x plus 5. That, when multiplied together, give us the proper sum. So 3x minus 1 times 2x plus 5, we know multiplying using the box method gives us 6x squared plus 15x minus 2x minus 5, which simplifies to 6x squared plus 13x minus 5. Awesome. You could also use the distributive property to check, and you would get 6x squared plus 15x minus 2x minus 5, which simplifies to 6x squared plus 13x minus 5. So if the directions on a problem just say to factor the trinomial into the product of binomials, this is what you're going to do. So go ahead and practice that here. You can write this in the guided practice box and push pause. We will come back in a second for you to check your work. 4x squared minus 11x plus 6. Okay, we're back. 4x squared minus 11x plus 6, written as the product of binomials, is 4x minus 3 times x minus 2. And this would be your work. We needed the numbers to multiply to 24 and negative 11. Actually, I'm going to work through that with you. But this should be your work if you got the right answer. If you didn't, let's go ahead and do that together. So again, we're looking for two numbers. I'm going to go through this quickly so you can hopefully identify quickly your issues. We're looking for two numbers that multiply to a times c, which is 24, and add to negative 11. I already have a bunch of numbers, a bunch of factors that I tried that multiply to 24, and I was looking for two that add to negative 11. So when we know that they add to a negative but multiply to a positive, they both have to be negative. 24 and negative 1 don't work. Those add to negative 25. Negative 12 and negative 2 don't work. That adds to negative 14. Negative 6, negative 4 doesn't work. Adds to negative 10. Oh, but look at this. Negative 8 negative 3, those add to, well, I guess I'll just write it. Oh, goodness. There we go. Okay, so negative 8 and negative 3, those add to negative 11 and multiply to 24. So I'm going to go ahead and fill in my box. See if that works. Okay. Nope. Just a second. All right, so I'm just going to write it. Okay, so I'm going to put my 4x squared here. And my 6 from my original problem in the box. And then my diamond gives me my x terms, negative 8x and negative 3x. Working backwards, the GCF of this row is just x, and then the GCF of this row is 4x. What times x gives me negative 3x? That's just going to be negative 3. What times 4x gives me negative 8x? That's going to be negative 2. And then I check to make sure, yes, negative 2 times negative 3 gives me 6. So this is how I end up with that answer, 4x minus 3 times, oh, not x plus 2. I hope that wasn't on all, was that on, oh, thank goodness. Not times plus 2, times minus 2. So let's fix that. Okay, so times x minus 2. Third example, the fully factored example. Now this is kind of weird because a fully factored example could be just factoring out the GCF. It could be just factoring a trinomial into the product of two binomials, or you could have to do both. And this should remind you of a page in your toolkit, the factored form page. We're always going to follow the same kind of thought process when we're asked to fully factor. First, we're going to look to see if there is a GCF. I'm going to make a little checklist here. Is there a GCF? It's the first step, always the first step. Look for a GCF. If there's a GCF, factor out the GCF and then ignore it. You ignore it till the end and then you tack it back on. Once you've factored out the GCF, you look and see if the factor without the GCF is a quadratic trinomial. If it is, let's see, what can I do here? What? If it is, what is happening? If it is, then I'm going to use a diamond and box to factor that quadratic into the product of binomials. Wow, this is so pretty. And then in the end, here's where a lot of partial credit happens. You factor out the GCF, you ignore it. You factor the remaining trinomial into the product of binomials. And then in the end, your original answer needs to include the GCF. So we'll look at this example as an example of a problem where we need to do both factoring of the GCF, factoring out of the GCF, and then factoring the remaining quadratic into the product of binomials. I've made my little checklist look prettier here, down at the bottom. So here is an example where I will need to factor out a GCF and then factor the remaining quadratic. So here's probably, I guess, the most complicated kind of problem that we'll face you with. So I think about my little checklist. Is there a GCF? Yes, there's a GCF of this polynomial. The GCF of this polynomial, we can talk about what that is. We look at the coefficient 2, 28, and negative 64. It's going to have a 2 in it. Looking at the x's, x to the third, x squared, x. The GCF is 2x, and I could have used the ladder or the box to work backwards to find that. So the GCF of 2x to the third plus 28x squared minus 64x is 2x. So I know this, so this is my partially factored form. 2x times x squared gives me my first term, 2x to the third. 2x times 14x gives me my second term, 28x squared. And then all I need to do is subtract 32, because negative 32 times 2x gives me negative 64x. So that is, if I had the directions, just write this in factored form by factoring out the GCF, I would be done. If not, for a little bit of time, let's see if I can just, that did not work. Well, let's pretend it worked. Maybe if I make it, nope. Well, we're just going to ignore that 2x for a while, and we are going to focus on the x squared plus 14x minus 32, because that is like my second checkbox. Does a quadratic trinomial remain? Yes, it does. X squared plus 14x minus 32 remains. So I'm going to ignore that 2x, and I am going to factor x squared plus 14x minus 32. I have my diamond in my box ready to go. So I'm looking for two numbers that multiply to negative 32 and add to 14. So thinking about what numbers those are going to be, one will be negative, one will be positive. So negative 32 and 1, no. Negative 16 and 2, no. Positive 16 and negative 2, yes. So 16 times negative 2 is negative 32. 16 plus negative 2 is 14. So those are my two numbers, my two factors here. Okay, so when we have, as in the case of this quadratic, when we have an a of 1, we talked about this, but maybe we've forgotten, we really don't need the box. We can use the box. So I think I already have it. Maybe it'll work. Will it work? Yes. We can use the box. So putting x squared, negative 32, 16x, and negative 2x. We can work backwards from that. What times? Oh, that's not working. I can put it over here. What times x gives me 16x? Okay, this is terrible. What times x gives me negative 2x, which is negative 2. And that's fine. I can use the box, but I really don't need it. Let's just write this here. Because I'm immediately able to identify the two binomial factors just from the diamond. So the two binomial factors of x squared plus 14x minus 32 are x plus 16 times x minus 2, or you could write it the other way, x minus 2 plus 16. But I can get that right here, right from the original diamond. And that's the case when there isn't a coefficient in front of the x squared, or the coefficient is 1. So you can use the box, but we really did not need to use the box in this case, since we had a coefficient in front of the x squared of 1. Okay, so again, this is a huge partial credit situation. If you write, like if I were to say, hey, I'm done, this is my final answer, x plus 16 times x minus 2, I would have for sure at least a -1 on my problem, because when we multiply this out, we're going to get x squared plus 16x minus 2x minus 32, which is x squared plus 14x minus 32. It is not 2x to the third plus 28x squared minus 64x. So my final answer, I include my GCF of, not just x, of 2x. My final answer is 2x, the GCF, times the factored form of the trinomial. So 2x times x plus 16 times x minus 2. The easiest way to check this is to use the distributive property for 2x times x plus 16, which gives me 2x squared plus 32 times x minus 2, and then use the distributive property again. And you'll see that you end up with 2x to the third minus 4x squared, minus 4x squared plus 32x. What is happening here? Oh, this is a 32x. Okay, there we go. So 2x squared times x gives me the 2x to the third. The 2x squared minus 2 gives me 4x squared minus 4x squared plus 32x squared, which simplifies to 28x squared, and then minus 64x. Thank goodness. So this is the most complicated fully factored example. And you have one more thing to do with me, which is your guided practice. Go ahead and write this one on your paper, x to the third minus 3x squared minus 28x, and press pause and come back and check your answer. Hopefully you press pause, you factored this polynomial, and you got an answer of x times x plus 4 times x minus 7. This would be your work. And again, because once we factored out the GCF, we had a quadratic with a coefficient of 1. We only need the diamond, we do not need the box. If you need some help with that, let's do that together. So let's ignore the answer for a little bit. We look at this polynomial, we look for a GCF. Yes, there's a GCF. This is a nice easy GCF. The GCF is just x. So we start our factoring. Two factors are x and x squared minus 3x minus 28. Again, we ignore this x for a little bit, and we just factor the x squared minus 3x minus 28 using our diamond. I'm just using a diamond because we do not need our, oops, oh. Okay, that must be old. Yeah, okay, so we don't need the box here because the a is 1. So we're looking for two numbers that multiply to negative 28 and add to negative 3. Thinking of some factors of 28, right away what pops into my head is 7 and 4. And yes, negative 7 times 4 gives me negative 28, and they add together to be negative 3. So without doing the box, since a is 1, I know that x squared minus 3x minus 28 is x minus 7 times x plus 4. And then partial credit situation, that does not multiply to give me my original polynomial. I need to stick the GCF out front, x. So x times x minus 7 times x plus 4 is my final fully factored polynomial. And you can see down here the order of the factors can be, well, x plus 4 can come before x minus 7, that's fine. Okay, you are now going to work on that individual practice. The top 4 tell you exactly what you're supposed to be doing, either just factoring out a GCF, factoring the trinomial into the product of two binomials, or fully factoring by first factoring out a GCF and then factoring the trinomial into binomials. On the bottom part, it says fully factor, but fully factor means maybe you just factor out a GCF, maybe you factor the trinomial into binomials, or maybe you do both.